morning. You're early again. In your old schedule.
So cute. I like either y'all want to buy chocolate for me? See, like I would. I just have no cash with me. Can Venmo me? Can you actually? You're not supposed to. I can just get cash. You might need to buy Miss Brian some dark chocolate. For real. That did me good on the last project. I got a 15.5 out of 16. What'd you get on the movie thing? I did not 15.5. I did not deserve that, but you know, I'm gonna go to the bathroom.
You just got I have Mr. Howard. Yeah. I'm not learning much, but that's okay. I don't remember. I got grade in there, so it doesn't matter. I don't remember it. Spanish 3. Like, I think I learned from the class that translating notes. So I learned basically learned like relearning everything every year. Did you have Barone? I had Barone listed for 4, but for 3 I had Miss Burns. Yeah, probably. But she's just really good. And I had Barone for Spanish 2. So, yeah. You know, I had Miss Reynolds for Spanish 1. Yeah, and then she should be good at that. She was good. I learned a lot. I like her notes. I like her. It says I have no internet connection on my phone. Here. Like a lot. First time I was like thing. And also Harper like rolled her ankle right before we went on stage and she had to go to the trainer and get it wrapped in a brace. And she did, but she didn't tumble because she couldn't tumble. Did she fire? Yeah. Well, this is just not real sleeping. Like before seniors, but it's just not. So many it's like insane. And it's like that from all the schools, though. Like all the cheer people are making this again. Like Harvard has a bunch of people out, Rikers has a bunch of interviews. Bentonville is hard, so we have like they're like fine. Yeah. I like better than I like something the cheer system. Yeah. It's a different. The coach is really old. Well, their JV is code, but it's a different guy. So they go against Bentonville JV, which is their like Bentonville JV is the one with JV. And it's just like yeah, that's true. JV cheerleading is good. I think the JVs are good. Yeah. I don't know about freshmen. Great. Freshman cheer is so good. Yeah. So that's not their fault, though. Yeah. Oh my god. There's no way. Oh my.
morning.
How are you, sir?
Okay, how are you?
Doing good. This is not anything major,
Okay.
and you may not even be needing.
Yeah.
Okay.
Thank you.
During the minute of silence, y'all will need a new piece of paper for 66. So if you don't have that out, now would be a good time.
Please stand if you are able and join me in the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you and have a great day.
All right, so we've got a couple things to look at today. Last time I saw you, we did something called Riemann sums. That was the left sum, right sum, and midpoint sums, ways to estimate area under the curve. And I'm going to have you practice some of that in a Khan Academy assignment. But first, there is one other type of area approximation called trapezoidal sums. So that is what this handout is over, and it really works out a lot of the same way. That's why there's not many examples here. But there are a couple of important pieces to pick up, and you can see how trapezoids can do the same thing instead of rectangles. Now with trapezoidal sums, there's only one of them. There's not like a left, right, and a center. But to be able to do a trapezoidal sum, we're going to have to remember the area of a trapezoid formula. So your AP exam expects you to have this memorized, so we have to expect you to have it memorized too. We would not provide this for you on a test. But it says take the height times the bases added together times 1/2. 1/2 times the height times the bases added together. So within that, you have to make sure, bless you, that you know the difference between the height and the bases. The bases are the sides that are parallel to each other. So you're used to seeing a trapezoid that kind of looks like this. So these would be the bases because they are the parallel sides. But you'll see when we do this, our trapezoids are going to look more like kind of tilted on their side. So in our examples, these are the parallel sides, so those will be the bases. Whereas the height is the distance between the bases. So this would be the height, how you probably saw it in geometry, but when we tilt this and it looks more like this, the height is going to be here. So you do have to know the area of a trapezoid formula. It is important. Just like Riemann sums don't really seem very calculus-like because the arithmetic's pretty easy. Same with this. Area of a trapezoid a couple times is not too difficult, but this will be on your AP exam. Oh, sorry, I did need to mention one other thing. I got distracted by the minute of silence here. So I didn't take this off yet until tomorrow. Tomorrow is a B day. It's a B week, so I will see you this Friday, but not next Friday. We decided not to do a couple question Riemann sum quiz this year, and instead 1 or 2 of the questions will go on the semester exam. Also, Ms. Cross felt like the semester exam being the normal 9 multiple choice, 1 FRQ, just puts too much weight on any particular question. So we made it a little bit longer, which means that you will need a little bit more time. So we will do the non-calculator part of the semester exam on the 14th, which is our scheduled time, and our calculator part will be the Tuesday before final exams. So that last week, Monday and Tuesday are normal classes, but for us, we're going to do a couple, I think it's 6 multiple choice and 1 FRQ, and then on the day of the final, you'll have 9 more and 1 more FRQ. So just want to give you that heads up. Okay, so I've got 2 pictures here of estimating area with the trapezoid, and these are kind of hard to illustrate. That's why I went ahead and stole some pictures instead of trying to make my own, because trapezoidal sums do such a good job that it's kind of hard to see. But this is supposed to be the function that they're estimating the area between it and the x-axis. And if you look really carefully, here's a trapezoid. Again, it's kind of tilted on its side from how you normally look at it, but it's got one pair of parallel sides. And then here's another trapezoid. And here's a third one. And a fourth one. So again, the more that you do, the more trapezoids you do, the more accurate it's going to be. Just like Riemann sums, the more rectangles you do, the more accurate it's going to be. But within reason, you know, we're not going to do a trapezoidal sum with 20 parts, just because that is would take so much time. So, but similar to Riemann sums, this does a good job of getting most of the area. Sometimes it does miss some area, but then sometimes it grabs some area that's not there. And so this stuff accounts for that stuff pretty closely, makes it a pretty good estimate. And then just one more kind of visual. If you wanted to estimate the area under the curve from A to B, you can see they drew in five trapezoids, and it gets pretty close. It's missing a couple spots, but it's also adding a couple spots that aren't there. In the end, it gets pretty close to being accurate without needing any complex calculus. So for your notes today, we're going to go over 2 of these that you can just follow along and copy down. Then we'll transition to the Khan Academies. I only have 2 Khan Academy assignments set aside for you. One of them has questions on left and right Riemann sums, and then the other one is on midpoint and trapezoidal sums. So, okay, so when I look at this one, we need to be familiar, even though you don't need to know how to work. This symbol is for integration, which is like the opposite of taking a derivative, and that is mostly what second semester course is about here. You don't need to know how to do an antiderivative like this. But that being said, you need to be able to know what the parts are for these questions. So this is the function that we're looking at. And since x squared is an easy one to graph, I think it makes sense to go ahead and just make a quick little sketch. Okay, so x squared is the function that we are estimating the area under a curve. These values tell you between what x values you want to know the area of. So we want to estimate the area from 0 to 2. So we are trying to estimate this area in that question, just from 0 to 2. That's all those numbers mean. So I don't really need that part over there, so just for simplicity I'm going to take it away. And I guess I will zoom in here, but this is telling us how many trapezoids to make. So they're saying split it up into 4 equal trapezoids. So in our picture, this is where I think the picture kind of helps, even though this one and my next one will probably be even worse because I'm pretty bad at making these pictures. We can try to draw in 4 trapezoids. So if I have a distance of 2 split up over 4, each trapezoid is going to have a height of 1/2. So there's trapezoid 1. It's really just a triangle because this base has no length. Here is trapezoid 2, trapezoid 3, and trapezoid 4. Again, it's kind of hard to even see the trapezoids because it just fits so closely to the function. It's such a good estimate that it's kind of hard to see them, but this is going to be plenty for what we need. Now for my arithmetic, I know that it's wanting me to take 4 trapezoid area formulas and add them up. So for me, I like to make 4 blanks just to kind of see the big picture. I know the formula for area of a trapezoid all include a 1/2. So each of those should have that. They should all have the height, which we should only have to think about once because the height of all of these is the same. So what do you think the height of our trapezoids are?
1/2.
Very good, 1/2. Remember that the sides that are parallel are the bases. These are the bases. This is the distance between the bases. This is the height. I know you're used to seeing it turned like this, but it doesn't have to be. In our case, it's turned like this. Distance between the bases is still the height. So this was 2 in horizontal distance divided over 4 times. So each one of these has a height of 1/2. So for my arithmetic, h is a half, h is a half, h is a half, h is a half. Okay, and then finally, if we can figure out those base lengths, then we can move on to the arithmetic, and we would be finished. Okay, so looking at my far left rectangle, or trapezoid, what is the length of his left base?
0.
Okay, it's right here. It has a length of 0. Okay, the length of his right base, I guess if I had to answer in 2 seconds, I might guess a half, but I don't think it is a half. For you to know what this length is, you have to realize this is the y value on the function x squared when x is 1/2. So if you plug 1/2 into the function, you would see that the y value there is 1/4. However far it's going up to hit the function is the same as the base length. Now here's where we get a little bit of a shortcut. Notice the length of the right base on the first trapezoid, compare it to the length of the left base of the second trapezoid. How does this length compare to this length? It's the same. So if you're careful here, you get to reuse that length again. Okay, now I need the length of the right base for the second trapezoid. It looks to be 1. If I have any doubt at all, I can plug that x value into the function, solve for y, and see that it is 1. And the length of the right base for the second trapezoid is the same as the length of the left base of the third trapezoid. This length is the same as this length. So if this is 1, that's going to be 1. Same exact length. Okay, for the third trapezoid, the right side, this looks to be about 2, but unless I am 100% sure, I should not assume that. I'd hate to do all of this work and then just be too lazy on one number here. So this is the y value when you plug in 1.5 for x into the function. So that ends up being 9/4, which is close to 2. 2 would be 8/4, but it's a little bit bigger than that. So again, I'm not relying on the accuracy of my sketch, but the sketch is helping me line stuff up. It's helping me see where these values are coming from. Okay, what about this length? Right, 9/4, then this is 9/4. It's the same length, so you can see we got to still the 1/4, used it twice, still the 1 got to use it twice, still the 9/4 got to use it twice. And then finally, what about the right side of the fourth trapezoid? What is that length? 4. And if you're not sure if it's exactly 4, if it just looks like 4, plug the x value into the function, and it's exactly 4. So whatever this mess of numbers adds up to is going to be the trapezoidal sum. Now, even if this was a calculator question, which it's not going to be, it would be a big mistake for you to try to type all this in your calculator. You're going to spend a lot of time, and if you miss one parenthesis, your answer is going to be off. So by hand, it actually works out a lot better than you would think, because all of these have a 1/2 divided by 2. What is 1/2 divided by 2? 1/4. So we can factor out that 1/4 as a GCF, and we're left behind a 0 plus a 4th plus a 4th. So I'm just going to say 2 of them, plus a 1 plus a 1, or 2 times 1, same thing, plus 9/4 plus 9/4, or 2 9/4, and then a single 4. So anytime it's a trapezoid where you're splitting it up into equal pieces, this is going to happen. This might be unique, this might be unique, but these links should repeat. Right side of the first trapezoid is equal to the left side of the second trapezoid. Right side of the second trapezoid is equal to the left side of the third trapezoid. That's why all of these values should repeat. Okay, and then now we're about finished. 0 doesn't do anything. 2 times a 4th would be a 1/2. 2 times 1 would be 2. 9/4 times 2 would be 9/2. A 1/2 plus 9/2 would be 10/2, also known as 5, and we end up with 11/4. So that's not the exact area, but that would be the estimation they are expecting from you if you were asked for a trapezoidal sum. So if you can do the area of one trapezoid, then you can do trapezoidal sums. You just have to be careful not to have careless arithmetic mistakes. Okay, any quick questions on this one before we look at one more example? Okay, let's do this again then. So, of course, sometimes you're not going to know what this looks like, but this one's fairly easy to sketch. This is going to look like x squared flipped over the x-axis and shifted up 4. So x squared flipped over the x-axis and then up 4. So something like that. But I care about x equals what to x equals what?
1 to 3.
That's what these numbers tell us. 2, 3. So honestly, I'm going to cheat a little bit. My picture is easier for me to see if I'm not looking at more than I need to. I really just need, let's do like maybe this. It's here, 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 and at 3 this would be -5. Since I only care about x equals 1 to x equals 3, I really don't want to look at more of the other picture. Again, my picture is still going to be bad, even though I'm putting in a good effort here. And I did this yesterday, so this is even with a little bit of practice. But again, your picture doesn't need to be very accurate. It's almost just a guide to make sure that you're pulling numbers from the right spot. But once again, we are doing 4 trapezoids. Of course, less would be easier, but I can't imagine you ever being asked to do more than 4 or 5. So I'm going to make 4 blanks. Since this is asking for trapezoidal sums, I need the area of a trapezoid, which includes a 1/2, so just kind of set up the skeleton here. I'm going to need to know the height of each of these. So if I try to draw in 4, this is where your picture is going to help a little bit. The first one would need to be about right here. The second one right there. And again, the bigger your picture is, the better, because go over here. Because it helps you see these a little bit, not so scrunched up. Okay, so there's my 4. So it looks like the 4 trapezoids are taking up a horizontal distance of 2. So 2 divided into 4 equal pieces makes the height of each one of these 1/2 again. Since they're all equal, again, you really only have to think about it once. Okay, and then we've got to do the basis, and this can be the messiest part, but you saw from the first example you get to steal some of this information. So right here, the far left of this, to me this looks like this is probably 3, but again, you don't need to assume. You can plug in that x value into the function and solve for y. That is 3. Here, I'm going to have to plug in 1.5. So 4 minus 1.5 squared is like 4 minus 9/4, which is like 16/4 minus 9/4, which comes out to be 7/4. So not the easiest arithmetic, but I get to steal that and use it here. The length of the right base of my first trapezoid is the same as the left length of my second trapezoid. Okay, what about this? How long is the right base of the second trapezoid?
0.
Okay, surely looks like 0, and plug in x, you can see that it comes out to be 0. If this is 0, then that is 0. Okay, now I'm here. So to find this is when x is 2.5, or 5/2. It's usually easier to do a fraction. So to know this length, it looks like it's a little bit less than -2, just kind of eyeballing it. But I could do 4 minus plugging this in, which is like 25/4. And then with the common denominator, 16/4 minus 25/4 would be -9/4. Now, does that even make sense? Why is this negative all of a sudden? Right, it's below the x-axis. Remember, area above the x-axis is positive, just like y values above the x-axis are positive. Area below the x-axis is negative, just like y values below the x-axis are negative. But for these, you don't even have to keep up with that. You can see, like, this is going to take into account the negative part of the area because it's below. Okay, so this length is the same as this length, so I get to steal that -9/4 one more time. And then finally, the last length. This length is y when I plug in 3 into the function. 4 minus 9 would be -5. Just like the first example, I think it would be a mistake to use the calculator even if you had one, because a lot of this will simplify as long as you kind of approach it the same way each time. Every one of these has a 4th, so factor out that GCF. Then I have 1 3, I have 2 7/4, I have 2 zeros, I have 2 -9/4, and I have 1 -5. Let's see, 2 times 7/4 would be 7/2. 2 times 0 would be 0. 9/4 times 2 would be 9/2, but it was negative, and a -5. Let's see, 7/2 minus 9/2 makes what?
-1.
Okay, so -2/2, which is the same as -1. And we end up with -2 minus 5 would be -7, so -7/4 unit squared's worth of area. So there's slightly more area below the x-axis and above the x-axis, which is why it's negative. But notice, I did not have to think about any of that area being negative. Anytime it was below the x-axis. Negative 3?
-1 -5.
3 minus 1 would be 2. Minus 5 would be a negative 3. Okay. Were we both wrong?
No.
Or just me?
Just you.
Okay. We'll just say we were both wrong.
Yeah.
Okay, so same thing. I didn't mean to do that, but I did the same thing yesterday. Just because you can do the area of a trapezoid, if you go too quickly and make a careless mistake, then of course, then that defeats the point of even doing the question. But now the area of a trapezoid formula, set it up, plug the numbers in. Worst case, you have to find numbers this way. Best case is they give you a graph and don't even tell you the function, which means that the numbers just line up with what the graph is, and you can just see the heights. You can just line them up over there, but this would be worst case. Okay, so now that you've seen a second one, any part of that you want to clarify before we move on? Okay, then you have 2 Khan Academy assignments. You can pick the order you want to do them. One of them has questions over left and right Riemann sums, which we talked about last time. I would suspect those are probably easier for you. And then the second one is mixed between midpoint and trapezoidal sums, but you may want to start with that one since the trapezoidals are fresh in your mind. So do your scratch work on 66, please, and then that would be the next thing I need you to achieve and get checked off. Of course, some of you are going to need more time on that, which is fine, but this is an important skill. So we've got to make sure that everybody's feeling pretty good about these by the end of class. But as you finish those, I also gave you the semester exam review, which is a little bit longer. I guess when you finish the Khan Academies, you can start to scan through it and see what it looks like, but I have the answers in the back, and the front cover sheet just kind of summarizes some of the more major topics and tell you which questions you could practice on those. So I will ask that you do at least 10 of those for homework, but again, you should have some class time to work on that. So I will give you a little bit of time to get started here, and then I'll come around once I think you start to find where you need some help.
Mr. Thompson?
Yes.
I know we're not allowed to exempt exams in this class, but is it all AP classes that you're not allowed to exempt exams?
Most AP classes don't allow exemptions. There are a few that do, but I couldn't name them off.
Okay.
It's more of like a PLC, so like
Right.
if all the AP World History teachers say we don't need a final, then they could do it without a final. But you just really need to talk to each individual teacher. But also that form for exemptions closes
I know. My
soon.
teacher just hasn't said.
So this is also
You need to check your student announcements.
I know.
Okay, okay.
this is also regarding finals. So I only have one final. Well, first you have an AP Calc class on 8th. Would it be possible for me to take my final with 3rd period? Okay, let's go.
Yep.
Because I have all my finals on Thursday and only one final on Monday. So I just wanted to.
On Monday?
Or not on Monday.
Okay.
Or
Yes.
Thursday finals. Yeah.
Mr. Rick just hasn't said whether or not he said, well, I have to think about it, so I don't know if it's like school policy. He's not allowed to.
No, Miss Barone is like
Well, Mr. Reeves also the department chair for AP department, so he has to set a good example.
Yeah, so I'm pretty sure I'm not going to be allowed to exempt it. I probably shouldn't, but I really don't want to.
Well, you can only exempt like 2 anyway, right? So,
I know. Yeah.
how many exemptions do you think you guys are going to get in college?
All.
Well, I'm not in college.
AP classes or college classes? Again, any of these questions that they don't just tell you what the function is, that means that you should be able to line up and see the length of each of those bases. Like you should just be able to see it from the graph. It should make it easier, not more work. And of course, if there's anything about this that you find difficult once you finish the practice, you should probably summarize that in words on your paper. So again, we have 1 or 2 of these will make the semester exam, since we're not going to do a couple question quiz over it. So I would think those would be easy questions for you, but everyone is different, I guess. Okay, does anybody need math help yet? Again, I am available to help here. Just kind of waiting until somebody asks and putting in grades as people finish. But speak up if there's something I can help you with. Okay.
Did y'all get this?
Yeah, you just basically take it right.
Well, why don't we do that? So like, I'm gonna make it in. To 3 unequal. Oh, unequal.
That's stressful.
Sometimes you just get weird stuff. Thank you.
What about Cody?
Yeah, I do too. Like, I have like all my track and soccer FHS stuff, but like I get that one out of my So I think I want that little dog one. Because I used to have that, but I let Lola's little sister Ruby borrow it, and I don't have it anymore, so yeah. She doesn't know where it is either.
Just learning question one. Well, I know. Did you start with one?
Yes.
You said 1, 2, 3. Okay.
All the way to question 3.
First period. You know, first period. I'm not gonna this week.
Oh wait, yes, I do. Yeah.
Yeah. I'm sorry. It's really, really diverse. Who did?
Someone under. You do it too. And so did you get it for the It's maybe like the 1 minus
No.
2x squared plus 1.
That's what our teacher said.
Because like the first couple of terms I never asked
this February. Usually there's like a few classes after. Probably yeah, and then I don't think that much of everything.
How did I do that? X squared minus 2x squared minus 1 is the numerator, because it's 1 minus 2x squared.
Okay. Did you put the answers for the FRQ on the back?
The answers to the FRQ are not there.
Okay.
I didn't get that.
I'm not sure if I have those written up, but I can do them before next week sometime.
Sounds good.
Are you starting with the FRQs?
I was going to, but now I'll just
So,
do the whole thing.
negative 2x squared plus 2. Yeah. Well, that's what I wanted to do. And then you factored it out and you got 2x squared minus 1.
You should have.
And then 2x minus 1 plus 1.
But then you have to multiply it by
Right. Or negative 2. Yeah. Yeah. So you have negative 2 x plus 1. And then you just 2 1 plus 1. I don't know what I was doing. Thank you. I did everything right until the last step. And I reworked everything. Barely. Yeah. When the it's undefined. So if you're trying to find out what it doesn't exist. So I guess that is pretty possible. I think I have a page on it. Yeah. Infinite limits, right?
Guys, how did you do 3? Put it in.
Oh wait.
Because like that's
Yeah, I mean, I'll plugged it into the top. Yeah. To see what X is approaching. Because what X actually is
okay.
since X does not equal 1, that means X it equals 5 everywhere it is. But it's approaching 5 on both sides. Even
Okay.
the actual value is 2. That's
Oh.
The 6C is supposed to be limit as X approaches 0 from both sides. Because it has a plus sign. How does one get 3 to 4? You try the algebra. I'm supposed to do that Oh, is it like when you go into you get them? No.
That's what it's in
Okay, I'm just trying to computer side.
No, it would be.
All right, guys, we're down to about 4 minutes here, so you need to find a stopping place. If you were working on those Khan Academies and you just need more time, then you have till class tomorrow, because we have class again tomorrow. Also, though, if you didn't finish that, you may not have made it to number 4 on the agenda, where I would like our notes and practice from last class turned in the Google Classroom. That should be marked at 64. And then on the semester exam review, you need to have, at a bare minimum, 10 questions completed. Again, it is longer, which is why I'm giving it to you a bit early and asking you to do it in pieces. 10 is, you're going to have a whole lot to do if you don't keep up with the benchmarks on that I ask you to do. So, but for now, it's time to find a stopping place.